Hello, 8th grade. I'm going to take you through this slideshow just like you were here in class. So what we're talking about today is molecules, and our two essential questions are, what is a pure substance and what can be represented with chemical symbols? Answer the two questions on the left. Okay, so how is matter classified? And it's classified by its composition. Tell me what composition is. So we're going to do a review and then we'll get into it. So the building block for all matter is an atom. An element is a substance consisting of a single type of atom, and each element has a symbol on the periodic table. Okay, so there's elements. So that would be just a single letter or a single chemical symbol. But a lot of elements exist as molecules. So if you see here, O2, that's two oxygen atoms that are bound together, is oxygen. O3, that is three oxygen atoms that are bound together, is ozone. Please answer where we find a list of all the elements. You will find that answer on this slide. So what makes these examples molecules? These are molecules because if you look here, it's two or more atoms bonded together. And this tells us, these little numbers tell us here that they're bonded together. But here, because there's no space, no plus, that is bonded together. And molecules can be made up of the same atoms or different atoms. Okay, so molecules are formed when two or more atoms bond together chemically. So the outer layer of electrons in an atom is called the valence electrons. And the valence electrons are the ones that can interact with other atoms. So oxygen here has 6 valence atoms, and for this valence shell to be full, it needs 8. And so these atoms move around looking to fill their valence shell. So these are two independent oxygen atoms, and when they bond, they each share 2 atoms or 2 electrons from their valence shells. So then we can count 1, 2, 3, 4, 5, 6, 7, 8. So each of the valence shells are full because they are sharing electrons. Okay, so compounds. We can look at different elements. We have sodium and chlorine. Or sodium is an explosive solid. Chlorine is a poisonous gas when they're by themselves, but when they chemically combine, they become sodium chloride, which we commonly call salt. So answer this question from this slide, please. Okay, so here you're going to be dragging these into whether they're compounds, molecules, compounds and molecules, elements, or molecules and elements. So as you can see here, each color represents a different type of atom. So for instance, this atom all by itself is an element. But this element would not be a molecule because there's only one atom. So that will go over here in elements. This has three different types of atoms. So that is a compound, but it's also a molecule. So you're going to put all 7 of these onto one of these somewhere on this Venn diagram where it is correct. Okay. Now, this is a chance for you to show a little bit about what you've learned. You're going to drag and drop these into these blanks. Okay, so when we're looking at different chemical formulas, is it an element? Is it a compound? compound or a combination. Now you're going to have to go into edit mode to do this, but let's look at oxygen. Is it a molecule? Is there more than one atom? Yes, but it's not just a molecule, is it? It's also an element. So we're going to go all the way to the right here, and you can actually click on both element and molecule, and if we pull that off, we're going to see a green arrow. If we had not done that, let's say we were like, oh, it's a molecule. When you pull that off, it'd be red. So as you're going through this, try to figure it out, not just pulling the pictures off. But when you're done, you should have green check marks in each spot. Okay. So chemical bonds are the result of sharing or exchanging electrons among the atoms. So we have two hydrogen atoms and an oxygen atom. Now, the first valence shell will only hold 2 electrons. The second valence shell will hold 8 electrons. So hydrogen wants another electron in its valence shell, and oxygen wants 2 more. So what happens is the hydrogen gets attracted to the oxygen, and they share their valence electrons. So now hydrogen has 2, and oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So chemical formulas. When we see these little subscript numbers, that means there are 2 atoms of that element in the molecule. So here we can see we have H plus O. H with a small 2 and an O. So you're going to write the chemical formula for C plus O. And I know it's hard to write a subscript. You can just put a regular sized number there for now. Now coefficients, they show up in front of the chemical formula. That means that there are 2 of those molecules. So when we see 2H2 plus O2, that means we have 2 hydrogen molecules. There's no coefficient here, so that's only 1 oxygen molecule. And when those come together, they become 2 water molecules, H2O. Okay. So you're going to be counting the molecules in each balanced equation. So the molecules are separated by pluses. This is what goes into the reaction, the chemical reaction, and this is what comes out of it. So there has to be as many atoms of each element on the left side as there are on the right. So if you look here, we count, there's 2 oxygen molecules, so there's 2 O2, so that means there are 4 oxygen atoms on the left. If we have 1, 2 here, because you see the 2, then we have 2 water molecules on the right, so that means 2 more oxygen molecules. So we have 4 here and 4 here. So you can see here that it shows, you can slide these bars up and down. So we don't have 4 O2 there on the left. There are 2 O2. So you can actually slide that up. And so that we have 2 O2 here. We have 1 CO2 here. And then we have 2 H2O here. So you're just going to slide these bars so that they match up. We have one CH4 as well. So you can see that that shows how many of the molecules are in the balanced equation there. And here we have 2 Fe, 2 iron, 3 Cl2. So you can just go through the rest of this and work that out. What is a pure substance? A pure substance has a definite and constant composition. The composition of a pure substance does not vary, no matter where you take a sample. For example, salt or sugar. Water is an example of a pure substance. Oxygen gas is an example of a pure substance. What is a mixture? It's not a pure substance. It's a combination of things. So a mixture can actually be separated. If you remember in the lab stations for atoms, it asks specifically about salt. It asked about why was there salt water, and then after the water evaporated, crystals were left, because salt water is a mixture, and if you remove the water, the salt is left behind. So an example is trail mix. You could separate out the M&Ms from the cashews, from the raisins. They're not chemically combined. Okay, so here's your word bank. So you're going to explain why trail mix does not make a good model for pure substances. So you're just going to put the information here. You can just go into edit and type the correct word in. Okay, so here you're going to be dragging all of these by one of these boxes. Either you're going to be dragging the correct. Okay, so we have diagrams here. So you're going to drag the property card to its each correct location. So each of these will go in one of the red boxes, and each of these will go in one of the green boxes. And you will do that from the edit mode. Okay, and now you're going, these are all text boxes. You're going to fill them in with the correct answer, and then any essential questions you still have. If you have any questions, please let me know, and hopefully this was helpful. Have a great day.